Hello everyone, we are group 14. My name is Naimesh and along with my partner Anju, we are going to present the topic of format string vulnerability today. I'm going to present here the contents which are mentioned for the presentation, which is the environment setup. Firstly, the what we require to exploit. Secondly, the format string, what exactly format string is, where it is used, and then the format string vulnerability, which we are going to exploit and will be shown in the demo as well. Later, the consequences of this attack, and some of the attacks, like how it is carried out, the entire thing with the code, and some few countermeasures about this format string vulnerability will be explained, and later the demo. So starting off with the environment setup, as this is tested by seed labs we have referred to. So for the environment setup, we would require a seed ubuntu virtual machine version of 20.04. Then the lab setup zip file, which can be downloaded from the seed labs website, and later the format string attack lab file. Starting with what is format string. It is a function which is used in a C language, which is printf, used to print out the string according to a format. So basically its first argument is called format string, which defines how the string should be formatted. It uses placeholders marked by the percentage character for the printf function to fill in the data during the printing of the format strings. So it is not only limited to printf function, but there are also other functions such as sprintf, fprintf, and scanf. So we can also use those as in format strings, right? So it is one concrete argument format with zero or more optional arguments. So some programs allow users to provide the entire or a part of contents in the format string. So the format string vulnerability happens when this program considers the input string as a command, the data which is added as input as a command. So hence attackers here, what they can do is they can come up with an input and with new behaviors that can jeopardize the security of the system. For example, they can inflict the segmentation fault on the running program, as well as they can execute malicious codes, or they can lead to reading the stack memory as well. So this may lead us to the consequences of the format string vulnerability. So our example here shows that the printf is used, causing the vulnerability in our exploit, which is contained in the format C file of our lab. So these are the consequences which this attack can take up, which is crashing the program, then which can they can also view the data on the stack memory. The attackers can view the memory at any arbitrary locations by changing the format in the string by giving a different malicious input. Then they can execute a malicious code entirely using that. They can also write the data in any arbitrary locations. So before moving on to the first consequences, we check by simply passing an echo hello command, so that we can confirm that our setup is properly running or no. So we see the docker images which we build, and we are turning it up, and we take the server address 10905, as we are going to exploit on that. And we can pass the echo hello command on the server to see if it's written properly, so that we can confirm it, the lab is set up right, the docker images are up and running. So moving on to the first consequence that we can face, and we are going to show that in demo, which is the crashing of the program. Hence, to crash the program here, what we do here is build a payload such that using the build string.py file, which helps us to make and install the payload, which will be shown in the demo, like how we make it, what commands are used. And we constructed its payload using a trial and error method, where we keep changing the count of this person.x 8x to increase the bytes in order to crash the program. So we print it like for 12 times, which lead us to crash the program. And so here in the screenshot we can see that the first when we checked for passing the echo hello, it returned properly, but now it's not returning properly, which is successfully we have crashed the program. So what it means, like the printf is not accepting the input which is specified, right? Then the secondly, we'll go to the printing out the server program memory, which is the stack data. So server program memory print out some of the data in the memory. The goal is to print out stack, so to identify that we how many times the %x format specifiers do we need to get in the server program to print out. It's like well, let's say the first 4 bytes of your input, so they can be printed out using that. We put the address in our payload as ABBCCDD, and you can see that the %x into 90, we identify the number to make a count of it. That way in the screenshot we can see that the address and to reach ABBCCDD, the address, we how many times it had to go, it prints all of those. Then the second is a heap data. So here the payload we generated is there's a secret message in the heap data. So the ideally the goal here is to find out what the secret message is and to print that. So the address of the string of the server printout, it will be printed on the server side, so the attacker won't be able to know that. So here our job here is to print the secret message. To basically achieve that, we place the address in a binary form, the secret message in a format string. So we again identify what number is to be put in there. Example just we got is at 63 to print the secret message out there on the server side. So we decide the distance between the starting point of the VLS pointer and the variable. That way we print the heap data secret message. So here thirdly we modify the server program memory. So now here the payload uses the %n. So we have to basically change the target value which is provided here along with the address. So to change that, we add the %n in the payload to print out the number of characters printed so far. So we can change the value and in the screenshot we can see that the first the address value was 11223344 and now it's 12b. So it changes the value successfully after we use this payload. Now over here we have to specifically change the value of the target to specified 5000. So here we what we do first is we convert the 5000 it into decimal. Its decimal value is 20480. So how the calculation is done is shown here, and we add the 4 at the end for the printf. So it sums out total to 20480. So basically we see that the new address we changed to 5000 is written properly as well using this payload. So this calculation has to be done again. Then for the third step over here, the server program memory, we change it to a large number. So this large number is basically divided into half. So we have to print like ABB, its decimal value, and then the CCDD, its decimal value, and then we can add both of that value, and then we can reach to this address. So basically this decimal calculation is done first, then we calculate one, this was 3707, and then we subtract it with the other. So that way we can reach to the server program memory with a large value. So here to understand better, we provide the stack layout diagram which shows clearly that where the main function holds the buffer address, which is the input provided by the remote users will be stored where. And this stack layout shows where the printf is invoked from inside of the myprintf function, which contains the format string, and how the vulnerability will take place over here. So now to inject the final step of malicious code into the server program, we'll modify the return address of the vulnerable code and let it point to the malicious code. So there's already an EBP address present which we get, and from which we will construct a new return address, and that will be pointing to the malicious shell code, which will result in injecting an execution of this malicious code. So however, the format string vulnerability exists in the server's programs myprintf function, which allows us to get to the server program to do more than what it is supposed to do, including giving us the root access of the machine. So here we can see that we just get the bin bash code in our exploit, and we just give the server IP, and then we can get the root access by just listening the server machine and passing in the netcat and exploiting the bad file. Then we can get the root access. We run the command who am I. We can do whatever we want once we get the root access. It's a reverse shell. So further will be continued by my partner Anju. She'll be presenting the demo and the countermeasures. Thank you.
Hello all, I will be providing the demonstration for format string vulnerability. So the first step we will be doing is to turning off the address randomization. So this is the command that we use to do the same. Now next we will be moving to the project setup lab setup file is there that we have downloaded from the setlab file. Okay, so the first we have to do the compilation. We'll move to the server code folder will be there. There the make file is there that will contains the compilation code and everything. We have to just run the two commands make and make install. Mm, so when we run the make a command that is during the compilation, two warnings are there for the print message. We'll do make install. Now, we will just move out of this folder. We can see that the Docker Compose file is there. Now, to bring the servers up and running, we have to run the Docker Compose build and Docker Compose up command. So we can run say build command that will create the Docker image, and then we will bring dc up or Docker Compose up command that will bring the containers up and running. So while these is starting, we'll open another terminal. We'll do doc ps. So this will show the current Docker servers containers that are up and running. These are the two servers. Now, of what we try to do is that we'll just send a message to the server and we'll check if that is coming or not. So we can like pass echo hello nc10.59090. We'll just we'll give control C. So we can see the message hello is printed and these are the address details that are provided by the program. Here we can see return properly. It means everything looks good and the message was given here. Now here we'll move to the app setter file attack code is there. Now uh, next we will be moving to the crashing of program. Now to do the same we have to build a payload so that the format string vulnerability will happen and the program will crash. So we have done the coding for the same in build underscore string python file is there. So we will just run that file to create the bad file and we'll pass this bad file to the server. So here if we list this we can see the bring build string is there. We'll just run this script and we'll see a bad file is created. We'll pass this bad file to the server. So here we can see the program have crashed as it has not returned the target variable value after and the return properly is not printed. It means the program has crashed. This is the first case. Next we will be moving to the printing out the server's program memory. So that is the stack data and the heap data we will be printing out. So for the same, we'll just list the files. So for to get the stack data, we have built a string, uh, build the string code underscore to here have the payload construction. We'll run this file. The bat file will be created, bat for underscore 2a. Now we'll pass this file 2a. We'll pass on to the server. We'll just try to print that. So we can see, so in the payload construction, we have provided the address to get the input of this address. Now, to reach this address, we want to know how many format specifiers we have used. We will take this much of data, we'll copy into a text file and get the number of the pipe symbol that are present. So that will be the number of count of ampersand that form ampersand x that format specifier that is needed. Now this is the count that we'll be using as a reference for the next payload construction. So that is 63. Now to get the heap data, we have a build string file. We have build string file underscore 2b is there. So in this, the payload construction to get the read the heap data, a secret message from the heap data, we will be running this and we will be that file is printed. 2b is there, bat file 2b. We just pass on it to so this. So if we can see here that the message in the heap is printed out. Now next we will be moving to modifying the server's program memory. So here we will be using the payload construction is done in the file 3a. So the first case is we have to print a different value at the target variable address. So the payload construction for this is done in this file. We'll run this. We'll check if the bat file is created. Now we'll pass on this bat file to the server. We can see 3a is there. Okay, so here if we come, we can see the target variable value is changed to like 12b. It was actually previously this one. Second case is the modifying the service value with they want the target's variable value to be 5000 hex. So the payload construction for that is written in the file build underscore 3b. We'll run that script and we'll check the bat file 3b is created. We'll just pass on this file to the server. Now here we can see on the server side the target's values is changed to 5000. Now next is the case where the target variable's value that is a server's program memory they want to change to AABB CC Now we have the payload construction written for the same in 3c. .py will run that the bat file will be created will sorry the bat file is created tracy will pass on this bat file tracy to the server. Now here we can see it's changed to AABBCCDD. Now the next step we will be moving is injecting the malicious code into the server program. So mm, the payload construction for this is written in the exploit.py file, py file. So we'll run this. We'll check if the bat file is created. We'll pass on to this to the server. So here we can pass like, oh, this is a bat file. So here we can see that the commands that were provided in the shell code that is executed, like echo success ls minus lsl, that will print the file names and everything. So in this way, the shell code is executed. Now the next case is the reverse shell case to gain the reverse shell access. Now uh, for that to be tested, we will open one more terminal also, new window. We will make it listen to 7070. Now to gain the reverse shell, the command that is return in this exploit reverse.p file, the payload construction, we will run this file and the will bat file for the same is created. We will pass on this bat file to the server. So here we can see we have gained the access. Now here we can do ls-l, that will list the mm, files details. Who am I? We can use. It will show root access is there. If config we can give, so this will provide the IP address. So these are the all tasks under format string vulnerability. So next we will be moving to the countermeasures. So below are some of the countermeasures. Compiler warning. First one is compiler warning. So whenever we compile the code, whatever warnings we get from the compiler, that should be taken care to avoid such vulnerability. Now, second is developer approaches. It means a secure style of coding should be adopted, such that such vulnerability can be avoided. Address space randomization, layout randomization. So it helps to create the dynamic addresses for the functions, variables that we are using. So the attacker will not be able to manipulate the address. Next is employee format guard. So format guard, that is a C library that provides protection against format string vulnerability. We can use the same. These are the references that we have used. Thank you all for listening to the video, and we are open for questions now.